analyze the beam shown in here with the help of Freecad FM software. So just launch the Freecad. First of all, go to Beam or any other Beam draft, you can use anything. First let's set the units. Default unit system meter, kg and seconds. So this means the force will be in Newton. Okay, now click on new file. So the beam is 4 meter length, 8 meter overall length. What I will do is I will put a point 1, 2 and 3 points. So to take a polyline, if you don't see this task window, the lines will be somewhere in here. Yes, here. See, this is the polyline tool, this is the line tool. You can use any of that. I will just use polyline. First of all, origin is 0 for all. Click enter, and then along x-axis press X. The x-axis will be locked. Now along X put 4000 millimeter, that is 4 meters, the first point. Okay, click enter. After that, then the x-axis is locked. Again press 4000 millimeters and press enter. Now those two portions are created, and now click close. I don't know what, but sometimes it will lag like this. Just wait. Now we created the length of the beam, and we need one more line. I will tell you why we need it later. 0 0 0. Click enter. Restrict Z axis by pressing Z, and input 500 millimeter. Press enter. Now we created one more line. Let's rename this line loading line. This is used to refer to the direction of the load. Okay, this is beam. You can press F2, or on Mac you can press enter, return key, or you can right click and click rename to rename these names. After this, switch to FEM. Now add an analysis container, and then add a material. You come here, and if all of these are expanded like this, close all of them, go to the standard folder and come to under metal, alloys, aluminum, copper, iron, steel. Pick this calculus steel. Okay, here you can see the material properties. This Young's modulus 210 GPa. Okay, that means here we have assumed 2 lakh Newton per meter square, but it will be 210. Okay, now the analysis object has the material defined. If the material has to be assigned to the sections, if we don't list the material spaces, if we don't refer to any elements, all the elements will get the same property. If it is having if the analysis container having only one material defined, the same material will be applied to all of the parts. Then we need to define because we are doing 2D FEM analysis, or 1D, we are using 1D FEM elements and we are doing a 2D analysis. Click on beam cross section. I will select the pipe. The outer diameter is 150. The thickness will be 1 centimeter, that is 10 mm. So that inner diameter will be 130 mm. Click on OK. Now first select the beam, this portion, and click on G mesh. Here take the 1D element type, take it second order. Let's do an element size of the length is 4000 millimeter. Let's split it into how much? Let's say 1000 millimeter, 1 meter. So 1000 is the maximum element size, and also set the minimum element size to 1000. Okay, so then there will be 8 meter, 10 elements in the beam. Click apply. This should run like this, and there should be no errors. And now click OK. Now that the mesh is defined, and let's go back to the figure. You can observe that point A and point B, both ends are simply supported. That means there should be a rotation at point A and also at point B. So let's create that in Freecad. To do the simply supported, we will use the displacement boundary condition. We will add those 2 points. After adding, click on add again, it will switch off. And now there should be no displacement in X direction, that means in horizontally restrained. There should be no displacement in Y, in 3D space Y there is no displacement, and Z also there is no displacement. Okay, this is simply supported. If we check these three also, rotation also, it will be fixed condition, so we don't have to check those. These are free to rotate in all the directions, and click OK. Now this is a simply supported is created. Now we have to define loading. Loading is here, this portion of 4 meter length beam has 30 kilonewton per meter load. That means overall this will be 4 3 is 120 kilonewton. Overall load is distributed over 4 meters. So that's what we will define in Freecad. This is the force load. Click on it, add, select this first portion. Now you can see the force is created. Let's give it the magnitude 120 kilonewton. 120 kilonewton. Okay, now we added that. Click on add to switch off the mode. Now we need to specify it downwards. That's for that we need a direction. Select this line, click on direction. Okay, we need to select that in the GUI. So this is blocking the line. Let's just switch off the boundary condition. The visibility, this is just visibility, and hide this one also. Now click on this line and then click on direction. It will take. Now switch on visibility of constraint force. click on reverse direction, it will act downwards 120 kilonewton. Click on OK. You can switch. For time being, let's switch off, and we have one more force of 30 kilonewton at this point. Again click on the force load, add, carefully select the vertices. It is hard to see that it is highlighted. You can change the display properties in the preferences. Now if you click, the vertex will be added, and now click on this line and then direction, reverse the direction. This is 30 kilonewton. Click on OK. Now that the concentrated force and the distributed force both are created, and the boundary conditions are also created. After that, add the solver object. Now click on the solver object and click on solver settings. Now this is a temporary directory where Freecad stores all the files. You can choose whatever directory you would like to use as where there will be input files, output files, all are written in that folder. I will just stick with this folder, but I will open this folder in the Finder. Okay, I will write the input file. Click on write input file. Here we are doing static analysis only, and run calculates. Now the analysis is completed. Now you can close this and go to pipeline. Click on CSX pipeline. Click on this one, wrap filter. First we will look at the displacements. Wrap options, displacement. Click on wrap, increase the wrap factor to make it visible, because the displacement will be minimum. We need to amplify them in order to visualize. Okay, this may be adjusted like 0.1, 0.01, whatever, just to make sure that we see the deformed shape. So the body is white now. See here, result display options, we can change it to wireframe, surface with edges, surface, just the nodes, outline. Many options are there. I will tick surface, maybe surface with edges. The coloring, we will take displacement and in the Z direction. You can see that maximum displacement is 0.513 meters. Whatever the displacement displayed in the viewport, in the Freecad viewport, is the unit that we have set in the preferences. Like what the unit we have set, meter, kg, seconds. So this displacement is in meters, that is 0.5 meters. That is way too much for any beam. Okay, this means we need to increase the capacity of the beam, like increasing the diameter, thickness, or adding the support, whatever. That is the next steps of the design process. But here we are interested in how to use the tool. So we got the displacement. Click on OK. Here rename this to displacement. Now add one more. Here take stress in XX component. This is not a vector, obviously. Here we don't have to. If you would like to, you can you can give wrap factor. I will just for time being just switch off the displacement vector. This is the SXX component stress. You, if you want, you can do it like this. I will prefer just try it one. Click on OK. So this is what we this is the stress which is what how to put it, we will calculate the moment from this stress. This is the stress which is causing the moments in the beam. In static analysis, in theory of structures, we calculate moments. Why? To calculate the bending stress. This is the actual bending stress inside the beam. Okay, this we can call it bending stress. Now for time being, switch it off. Click on this surface. Let's take XZ plane. There is a stress in XZ component. This is what? This is shear stress. This is what shear stress is. You can see that at the at this point A, the shear stress is minus 2.387 10 power 7 Newton per meter square. This is the stress, with shear stress induced at point A. Okay. You can visualize one component at a time. You can see displacement, bending stress, shear stress. Now the analysis return these files. First one is input file. It will be the input file we already, I think we have not seen, I guess. I will open it. It can be opened in any text editor. So this is the input file that this calculus solver was given. This input file was given to this calculus solver. Here it lists the nodes and their location x, y, z. Observe that y, z's are all zeros. Only in x we have different nodes. Also you can observe there are so many nodes, but we just created 3 nodes when we are defining the beam. The first node is 0 0, the second is 4000, and third is 8000. What are all these then? Then we meshed the beam at 1 meter length. So for every 1 meter a new nodes are created. Okay. So this after 3 nodes, all the remaining nodes are created due to the nature of the solver. This is responsible for this part. The solver is the responsible. Okay. Now next they define the elements. Next it contains many information like the pipe section, material, calculus steel, elasticity, I mean Young's modulus. Okay. constraints, output file, node displacement, stresses, strains, all these are put in the output file. Okay, see, this says that the following units are used to write the input file. Okay, length millimeter, time seconds, temperature Kelvin, mass ton, mass is in ton. This information is helpful while doing dynamic analysis. For dynamic analysis, the weight will be considered, right? There, this will be useful. So the force will be newtons, pressure is newton per millimeter square. Observe that this is input file for the solver, but in Freecad, when we are viewing the result, the units what we have set in the preferences will be used. So all the results from the solver are converted to the units that we have set and displayed in here. So in the viewport, what we see displacement is in meters, but in the solver it was in millimeters. Okay, that's one thing that you can keep in mind while using the Freecad. Let's close this. This is just input file. There is also an output file, that is FRD file. We'll open this file. In this file, what we will get is, first of all, the nodes are renumbered. So these are the nodes. These are all the nodes. For every point on 2D graph, this is what happened is, the calculus is a 3D engine and it always calculates in 3D space or do all the calculations in 3D space. So this is a 3D mesh. Okay, this is at point A, this is X, this is Y, and this is Z. At X, see, 0, X is 0, there will be 1 2 3 4 5 6 7 8, overall 8 nodes are there. It looks a little bit confusing, don't worry. Here are the displacements. All of the displacements here in this file are in millimeters, and we have stress. The stress is also in newton per millimeter square, not meter square. The output file will have the newton and millimeter square as we have seen in the input file. Okay, let's keep it aside.